साउंड बंद करने बोलो. Hello, good afternoon everyone. Hello, good afternoon everyone. Welcome back to SISYA CLASS YouTube channel. Today we'll be continuing our JEE Maths Foundation series with the chapter Permutations and Combination. This is an easy mark scoring chapter, my friends. Please listen carefully. Let me introduce myself. I am Pawan Yashwant, a graduate in Bachelor's in Technology from Gandhi Institute of Technology and Management, Visakhapatnam. So what is permutations? Permutations is all about arrangement. It is finding the number of possible arrangement for a specific set of elements. Now coming to the basics, the first thing we'll be learning is fundamental principle of counting. What does it state? Let us see what does it state first. If one task can be done in m number of ways and another task can be done in n number of ways, then the total number of ways to perform both tasks together is m into n. Let me take an example, right? Okay, you have 3 pens, 1, 2, 3, right? And you have 2 notebooks. One, 2. Now you can write first pen in both the notebooks, right? Second pen with both the notebooks, and third pen also on both the notebooks, right? So what is the total number of ways this can be done? It can be done in m into n number of ways. M into n number of ways. Okay, now coming to permutations. Okay, and we have this principle is also used to calculate the number of possible outcomes when 2 or more events occur simultaneously. If you have 2 or more events happening at the same time, if you want to know in how total many ways they can happen, you can use this formula m into n. Right? Now we'll learn about fractional notation. If n is a positive integer, then the product of first n positive integers is denoted by n factorial. N factorial is nothing but it is the product of terms less than or equal to n, that is n into n minus 1 and so on. Let us take an example. If you take 6 factorial, this would be 6 into 5 into 4 into 3 into 2 into 1, right? We define 0 factorial as 1. This is an important thing to remember. If you see a 0 factorial, it's not 0, it is 1. Now coming to factorial table. Different numbers, every number has a different factorial value. You can find out using this table. 1 factorial is 1, 2 is 2, 3 is 6, 4 is 24, 5 is 120, 6 is 720 and so on, right? Now coming to permutations. Let us see the definition of permutations first. Permutation, each of the arrangements which can be made by taking some or all of the number of things is called a permutation. Permutations implies finding the number of possible arrangements. And the important thing to remember here is order of things happening is important. In what order they happen is important to consider. Okay, right? Coming to okay, let me write the formula. NPR is equals to n factorial by n minus r factorial. Here n is the total number of terms, r total number of components, r is the set of components that you want. Okay, it could be 6C, 6P2, 6P3 and etc. Right? Now coming to permutation when some objects are identical. Let me give you an example. If I give you 1, 1, 3, right? If you change these two terms, it is still the same arrangement. You can see it, right? So in this case, we will be dividing n factorial by the terms that are getting repeated themselves, and the number of times are getting repeated themselves. So permutations of n objects taken are at a time where some objects are in identical can be calculated using the formula. So in this case this will be 2 factorial, right? Let's continue. This is the general formula of permutations. It is important to remember that in this case repetition is not allowed. Okay, if repetition is not allowed, the formula would be different. Okay, now if repetition is allowed, let me give you an example. If you have an arrangement like this and you have to fill some numbers 1, 2, 3, 4, 5 and 6. How would you fill it? You would fill it in, for the first, you would fill it as 6 factorial, 5 factorial into 4 factorial. So the total number or the formula is given by n power r, where n is the total terms, r is the number of times it is getting repeated. Coming to circular permutations. Now in this, the permutation is given by n minus 1. Let me tell you the difference between this and a linear permutation or linear arrangement. 1, 2, 3 and 4, right? Let me take x, y, z and w. Okay. Now let me come to circular arrangement. In this also, let me take 4 people. X, y, z and w. Now in this case, let me push x to one place on the right hand side. That would be w. If x goes here, let me write x, y and z. If you see, every position of every term is changed. Now let me try to change it here. Let me write or change the position of x one place. That should be x, y, z and w. Is it different, guys? If you observe, the same persons are sitting beside each other, so the arrangement is same. The person sitting next to each other are not changing. Even if you do it for 4 more times, that would be same. But that is not true in this condition. That is why in circular permutations we have n minus 1 factorial. Okay, guys. Now coming to combinations. Combination is all about selection, my dear friends. It's about selections. Each of the group or selections which can be made some or all of a number of things is called a combination. You could be taking an example of a salad. You would be adding apples, bananas and cherries. The order in which you added does not matter. You could add apple first and banana later, or banana first and cherry later. In any ways you can add them. So in this the formula would be C N C R, right? The formula would be NCR. Let me tell you the formula. It is n factorial by n minus r factorial into r factorial. Hi, hello Nidhi ma'am, Ramki sir. Now in combinations, the order in which the things are taken is not considered as long as the specific things are included, right? Coming to the general formula of combination that I have told you, n factorial by n minus r factorial into r factorial. If you see it by condition of PR, NCR into r factorial is equals to NPR, right? Or it can be written as NCR is equals to NPR by R. If you divide it, you would get NCR. Coming to, these are 2 important conditions, Nana, to remember while solving combinations. You will be learning this in binomial theorem. NCR is equals to NC n minus R. If you are selecting R components out of n, that is same as removing of R components from n. This is an important thing to remember while solving sums. Coming to block method or string method. What does it say? The block method is used to calculate permutations of n different objects where R objects are always together, right? In this method, we treat R different things as a single block and calculate the number of permutations. Furthermore, the R different objects inside the block can also be permuted. Now let me give an example. If A, B, C, D, okay, E. Now, what is he saying? If we will remove a block of items, he'll say last, assuming D, A, B, C, D and E, a different block made of D and E. He'll give a condition to solve this. He is saying we should take these terms, which are these terms, 3 terms, and the whole block as 1 term, and this whole block can also be permutated by 2 factorial times, DE and ED. Got it, guys? Nice. Okay, how many permutations of the letters of the word Mississippi are there in which all 4 S's are together? Okay, let me write. P. Okay, what is he saying? Let us remove the 4 S's. 1, 2, 3, 4, 5, 6, 7. Right? We have 7 terms other than 4 S's. This is a whole block. And one more block is 4 S's. And he is saying in which all 4 S's are together. They should occur together no matter what. This is 7, this is 1, right? So the total would be 8 factorial. Now we have learned that if the components are repeating, we would remove them or divide them with its factorial. You can see, let me tell you, S, S, S and S. These are 4, right? It is a 1 block. Let me tell you, no matter in which way you write these 4 S's, the pattern will not change. S, 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 S will only be like this. So it is 4 factorial upon 4 factorial, right? The value would be 1. Now coming to the other terms that are getting repeated. You say, can we see I am repeating? No. Is I repeating? Yes, 4 times. 4 factorial into. What is the another thing that is getting repeated? I can see P getting repeated. Right? Now let's see the value of 8 factorial, or you can write it like, yeah, 8 into 6 into 5, right? By 4 factorial is getting crossed here. 2, 3. So answer would be 840. 15, 24 into 6. 4 factorial, 2 factorial. Now coming to gap method, friends. Let's learn what a gap method is. Gap method is used to find if we have to arrange n different things in such a way that no 2 things of the R things are together. In this method, we first place n minus R things in a line so that there are n minus R plus 1 gaps in between and at the extreme ends. Now place R things on this gaps so that no 2 of these things are together, provided the condition n is less than or equal to n minus R plus 1. He is saying, let me give an example. If you are sitting like this, let me tell you a question. We'll solve it in a question actually. See, how many ways 10 boys and 4 girls stand in a line such that no 2 girls are together? Let me first arrange the boys. 1, 2, 3, 4, 5, 6, 7, 8, 9 and let me write 10 here. These are 10 boys, right? How many gaps we have? Girl can sit here, sit here, sit here, sit here, sit here. Let me erase. right? Girls can sit in all these places and boys can sit in these places. Now we have 10 boys sitting in a linear arrangement. What have we learned? If they are sitting in a linear arrangement, they can be arranged in n power r or n factorial ways. That should be 10 factorial ways. Okay, we are arranging boys in 10 factorial ways. Now coming to girls. How many girls we have? We have 4 girls. And let's check the gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? We are filling up 11 places with 4 girls. That should be 11C4. Now, these girls, how many ways can they arrange themselves? Girls can arrange themselves in 4 factorial ways. So, the answer is 10 factorial into 11C4 into 4 factorial. Coming to a question. NC3 find NC3 if NC7 is equals to NC4. Right, we are asking to find the value. Let's find the value of n. The value of n, if you remember this, yeah, NCR is equals to NCN minus R. NCR is equals to NCN minus R. If we compare this equation with this, what would we be getting? R is equals to NC7 is equals to NC4. N minus 4 is equals to, we have 4, right? R, we have the value of R, which is 7. N minus 7 is equals to 4. N is equals to 4 plus 7. That's equals to 1. Hello Abhinay, hello Himanshi, right? And now we are asking to find the value of 11C3. You can find it. 11 factorial by 11 minus 3 is 8. 8 factorial into 3 factorial. N factorial by n minus r factorial into r factorial. Now, okay, let us solve this. In how many ways can we select 2 vertices in a hexagon? He is talking about selection, so we will be using the formula of combinations. Vertices, number of vertices hexagon would be 6. How many do we have to select? 2. 6C2. Right? This should be 6 factorial upon 6 minus 2 factorial. 4 factorial into 2 factorial. So this should be 6 into 5 upon 2. Right? Into 4 factorial will be crossing out with the denominator 4 factorial. This should give me 5 into 3, that's equals to 15. Okay, these are the ways we can select 2 vertices in a hexagon. Coming to this question, it has been asked in JEE 2025. The question is the number of words which can be formed using letters of the word daughter so that vowels never come together. Let me write DAUGHTER. Vowels is equals to, how many vowels we have? A, U, E. We have 3 vowels. Consonants, we have 1, 2, 3, 4 and 5. Right? 1, D, G, H, T and R. We have 5 consonants. Now, he is asking vowels never come together. Let us find out the condition in which vowels come together, right? Hello Abhinay, hello Himanshi, how are you doing? Yeah. Guys, tell me in how many ways this whole word can be arranged? It can be arranged in 1, 2, 3, 4, 5, 6, 7 and 8. 8 factorial ways the word can be arranged. Okay. Now, let us find what if vowels come together. vowels come together. What if vowels come together? We have, if we use the block concept we have learned, this whole 5 will become one block. Sorry, this will be 5 and this vowels would become one block. Am I right? Okay, so the total would be 6 factorial. We have also learned that words or letters inside the block can also be permutated. How many ways? They can be permutated in 3 factorial ways. We have 3 vowels into 3 vowels. Am I right? Now, if we remove the total combination, the total combinations minus if we do this, if we remove the total minus the terms in which vowels come together, we would be getting the asked question, that is vowels never come together. Vowels never come together. So that should be 8 factorial minus 6 factorial into 3 factorial. Am I right? So that should be, if we take common, 6 factorial, 7 into 8 minus 3 factorial is 6. 56 we have, okay, this can be 6 factorial into 50. 6 minus 6, 50. The answer we would be getting is 3600 ways, because the value we have found. Value of 6 factorial is 720, and if I multiply it by 50, we would be getting 36,000. Got it, guys? First, we found out the condition in which the vowels come together. See, I haven't done nothing. Vowels are 3, we have 3, A, U and E. They can be arranged in 3 factorial ways: AUE, AEU, UAE, UEA and EAU and EUA. Great. Now if I subtract the total combinations from the arrangement in which vowels come together, we would be getting the condition where vowels never come together. So that is what we have done. We have subtracted total minus the condition in which vowels come together. Right? Coming to other question. If all the words with or without meaning made using all the letters of the word Nagpur are arranged in a dictionary, then the word at 315th position would be. Okay, guys? They are saying dictionary. First one would be A, right? In the dictionary order, we will be getting A, B, C, D, E, F, G, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. This is the arrangement, right? This is the arrangement if I am ordering them in dictionary method. Great. Now tell me, how many words can I form with A? How many words can I form with A? Just a second. Hello. Hi. Yes. A. How many? 5 factorial ways. I can arrange them in 5 factorial. That should be 120. 5 into 4, 20. 20 into 3, 60. 60 into 2 is 120. Now, how many ways can I arrange G? G can also be arranged in 5 factorial ways, which is 120. Okay, coming to N. How many ways can I arrange N? Same. 5 factorial, 120. Now guys, please listen. Add the total. 12 to 24, 12, 36. We are getting 360 words still here. But we need to find out the 315th term. 315th 15th term. So the letter or word would be lying in N, right? Since G is completed, the next word or letter it will go to is N. Okay, now let us arrange N. NA, let me write NA, because after starting from N, the next letter that comes from this arrangement would be A, right? NA. How many words can it form? It can form 4 factorial, right? 24. Now, after NA, what would be coming? NG. This would be again 4 factorial base. Coming to next, NN. Can I write NN? No, because I have already used N. Now we'll write NP. NP is equals to 4 factorial base. Now please check how many we have completed till now. We already have 240. We have 240 already done. 240 plus it's 12. 6, 12, 72. Right? We are done with 312 words. 312 words. That means the next number would be a 12 after this. Right? So we'll start arranging in NP. Great. After NP we'll start arranging. Great. Okay. How can we arrange? NP. Okay, we'll write NP. Just a second, guys. Hello, hi. Okay, NP. After NP, what are the terms we are having? Let me write AGN. PRU. PRU. Just 1 second. We are done with these many words. We have completed 312 words, right? The next letter that would be starting would be NR. We would be starting our arrangement would be NR. Let me tell you why. Till here we have completed 312 words. The next series that would be starting is NR, right? So let us check. NR. After R we have A, G, N is done, P and U. Okay, we are left with this. Just a second. NR. NR. Now, what this is the term. This first thing after this would be changing the last 2 terms. That is the first term we will get, because these are the last 2 terms. That means they are coming in the later order of the dictionary. Let me write it as N, R, A, G, U and P. Okay, this is the which word? 314th word. Am I right? 314th word. Now the next word would be changing this. From this we have to change this. Great. N, R, if we interchange this, G, P, U. I guess this is the answer. Sorry, we are interchanging this. This is the 315th term. Coming to the next question. Now, if the numbers of the words with or without meaning, which can be made using all the letters of the word mathematics. Hi, hello ma'am, hello. Without meaning, which can be made using all the letters of the word mathematics, in which C and S do not come together. C and S do not come together. How many ways can we write mathematics in? Mathematics. Mathematics. How many ways can we write this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can write this in 11 factorial ways. Now, if we subtract the ways in which C and S come together, then that would be the case where C and S won't come together, right? Total minus a part would give us the remaining answer that we want. Do not come together. Let's do this. Let us find the case C and S come together. Right, C and S come together. We can do this by, let us remove C and S. How many would we having? 1, 2, 3, 4, 5, 6, 7 and 8, 9. We'd be having 9 and one more block, right? This should be 10 factorial. Okay. Now guys, this is not complete. This is 11 factorial upon, let us remove the terms which are getting repeated, right? If they're repeating, they're making the same arrangement again. To cancel that, we have to divide it. We have, is M repeating? Yes, 1, 2, right? M is repeating 2 times. A is repeating 1, 2 times. And T is repeating, T is also repeating 2 times. Do we have anything else? H? No, we do not have H repeating. So this is the arrangement. Now coming to this case where C and S occur together. In this we have 10 factorial upon 2 factorial upon 2 factorial into 2 factorial. Now if we subtract the complete case from this, the second case from the first case, we'll be getting our required condition. That should be 11 factorial upon 2 factorial into 2 factorial into 2 factorial minus 10 factorial upon 2 factorial into 2 factorial into 2 factorial. Guys, in block we have to again permutate the inside objects which are C and S, CS and SC. That should be 2 factorial, right? Into 2 factorial. Okay, now let's cancel this out. Now what did he say? He said it is equal to 6 factorial into k. Then we have to find the value of k. Okay, how can we do this? Let us take 10 factorial upon 4 factorial as common. 2 factorial, 2 into 2 is 4, right? Into 11 factorial, 11 into 10 factorial, 11 upon 2 minus 1. Okay, this should be 10 factorial upon 4 factorial into, this is how much? 9 by 2. 9 by 2. Now, since in the equation we have 6 factorial, let us keep 6 factorial and multiply the remaining terms. 9 into 8, 10 into 9 into 8 into 7 into 6 factorial by 4 into 9 by 2. Right? You understood this? Great. 2 5s, 4 2s. Okay. Now we have 70 into 63. Right? That should be just a second. This is 9 5 is 45, 45 is 2 90s, 90s, this is 90 into 63. The value of k would be 5430. Got this? We found out the value of k by solving this equation. How? Finding the all combinations together and removing the combinations in which the two terms occur, C and S. Great. Let's go further. Yes, just a second. Okay guys, the answer is 5370. 670. Now coming to this, number of arrangements of the letters of the word independence in which all the vowels occur together. It's simple, right? Independence. Now, what are the vowels we have? I, E, 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 E. I and we have 4 E's. If we use the block approach we have learned, how can we write this? 1, 2, 3, 4, 5, 6, 7. 7. And this one whole thing is one block. That is plus 1. 8 factorial, right? We learned this 8 factorial upon the terms that are, let me also write this, we can arrange them in 5 factorial ways. Upon the common terms, we have 4 into, okay, we have this one 4, n, and n, 3 factorial into, we have sorry, not E is done, and D, yeah, 2 factorial. So we are getting 8 factorial into 5 factorial upon 4 factorial into 3 factorial into 2 factorial. Great. Now how can we solve this? Let's cancel this out. 5 into 4, this thing is done, upon 2. This should be 4 into 7 into 6. Right? This should be 16,500. Right? 16,800. Yes. Coming to next question, we have the number of ways in which 5 girls and 4 boys can be seated around a table so that no 2 girls can sit together is. Let me take a table, right? Let me first arrange the boys. 1, 2, 3, 4, 5, 6 and 7. Okay, these are the boys. 5 girls. Let me take the remaining places. 1, 2, 3, 4, 5, 6 and 7. Right? 1, 2, 3, 4, 5, 6, 7. 7 boys and the gaps 1, 2, 3, 4, 5, 6, 7 gaps. Right? How can we write this? 7 boys can be arranged. Okay, the thing is no 2 girls are together. That means there's a girl in between a boy and a girl. That is the condition we have. Right? We can arrange the girls in 7p5. Am I right? 7 places girls can be arranged in 7p5 ways. And how many ways the girl these can be arranged, boys can be arranged? They can be arranged in 7 factorial ways, right? Or we can write it as 7 just a second. 7 factorials. The boys can be arranged, girls can be arranged in. Guys, this is the important thing. How many ways the boys can be arranged? This is a circular arrangement, n minus 1 factorial. So it is 6 factorial ways. This should be 6 factorial ways in which the boys can be arranged. Coming to the girls can be arranged in 7 P5 ways. This should be 6 factorial into 7 factorial upon 7 minus 5, 2 factorial. This should be, if I take 6 factorial is 720 into 7 factorial. Seven factorial we have is 5040 upon 2. You got this? 6 factorial into 720 into 540 upon 2. You would be getting, okay. The options are in factorial base, right? Okay. We have 6 factorial, right? This can be written as 6 factorial into 7 factorial upon 2 factorial would be 720. No, this thing can't be done because value of 7 factorial is more than 720. Let us check 5 factorial. How? In this case, let us try removing 5 factorial. 5 factorial upon, how would this be? 6 into, this would be 7 into 6, 42 upon 2, right? This should be 21. So this would be 5 factorial into 6 ones are 6 and 126. This is the answer. Just me write 5 factorial into 126. 2 1s are 2, yeah. Guys, factorial into 126. Let me check. Okay, 7 factorial by 2 factorial. Okay, let me check it later, guys. The number of 7 digits integers with sum of the integers equals to 10 and formed using the digits 1, 2 and 3. Guys, this is a question where you should be using 1s, 2s and 3s and the total integers. Sir, Hindi nahi bol pate kya aap? No, I can't actually. Okay, I can't. Okay, you have to use 1s, 2s and 3s, but the total integers should be 7. 1s, 2s and 3s. Okay, how many 1s, 2s and 3s such that I can get this sum as 10? This sum as 10. I can use 5 1s, right? 5 1s is 5, 2 1s is 2 and 3 1s is 3. 5 plus 2 is 7, 7 plus 1 is 10, 7 plus 3 is 10. This is one condition, and where the sum of the number of terms would be 7, right? What is the second condition that I can use? I can use 4 1s plus 3 2s. This should also give me 7. 7 is the integer, number of integers. These are the numbers. Now, can I use 3, 2 and 1? 3 1s is 3, 2 2s is 4, 3 plus 4 is 7, 7 plus 1 3 is 10. No, because if you add this, you would be getting total of 6 terms, which we can't use, right? Now coming to this, how can you arrange them? We have learned this 7 factorial upon 5 factorial, right? Because 5 1s are common, and this can be 7 factorial upon 4 factorial into 3 factorial. Now let's add this. What would this be? 7 into 6 plus, because 5 factorial is getting cancelled, 7 into 6 into 5 by 6. If I cancel this, 42 plus 30, sorry, 35, sorry, 42 plus 35, we'd be getting 77, right? Let's solve the next sum. A scientific committee is to be formed from 6 Indians and 8 foreigners, includes at least 2 Indians and double that number of foreigners as Indians. Double the foreigners as Indians. The number of ways the committee can be formed. Okay? Okay, just a second. Indians, foreign. What is he saying? 6 Indians and 8 foreigners are there, which includes 2 Indians and double that the number of foreigners. Okay. If I take 2 Indians, there would be 4 foreigners, right? If I take 3 Indians, there would be 6 foreigners. If I take 4 Indians, which is possible, I'll have 8 foreigners. Can I take 5? Can I take 5? No, because there are only 8 foreigners. If I take 5, I'll have to get 10 foreigners. This is selection, right? How can I choose this? Number of Indians are 6, foreigners are 8. How can I solve this? The first one would be 6C2 into, this is 8C4. You understand this? We are selecting 2 out of 6 and 4 out of 8. This would be 3. 6C3 into, this would be 8C6. This would be 6C4 into 8C8. This would be 1. Now, if we add them, then that is the total number of ways the committee can be formed. That should be 6C2 into 8C4 plus 6C3 into 8C6 plus 6C4 into 8C8. So this should be, if I directly write the values, this would be, okay, this would be like 15. If I calculate, how can you calculate this? 6 factorial upon 6 minus 2, 4 factorial into 2 factorial. You have to solve all of that. You can be getting the answer as 15 into 70 plus 20 into 28 plus 15, right? That should be 1625. This is the answer, Nana. Okay. I hope you all have enjoyed this session. If you want to learn more topics like this, we are coming up with a SISYA Elite batch for the grades 8th, 9th, 10th, 11th and 12th, craft completed by the IITians themselves, right? Guys, why do you think we have to start early? If you're in 8th class, you'd be having around 5 more years in your hand. If you're in 9th, you'd be having 4 more years. If you're in 10th, you would be having 3 more years. Let me tell you guys, if you are starting early, you would have that time to build up your foundation, a stronger foundation which is needed in an exam where 13 lakh students have appeared this year. 13 lakh students have appeared this year, guys. And out of this 13 lakhs, around 2.5 lakhs have moved to the advanced level. So starting early would give you a better foundation, which is extremely necessary, and it will also help you to manage the time that you have, and it will give you a better time to develop your critical thinking abilities, the ability to find the logics and etc. And it will also help you to feel the real competition by giving mocks and mocks, test series and etc. Now coming to who is gonna teach you in this foundation series. We believe expert teachers can make expert students, so we have IITian team who are gonna teach you in this foundation course. They can help you by sharing their journey, their experience and their thoughts with you. Now coming to syllabus, what will we be covering? We'll be covering complete 11th and 12th JEE syllabus, starting from scratch to JEE advanced level. Now the course is going to start on June 2nd. It will not be live on YouTube. It will be live in SISYA CLASS app, where you will be able to access live quizzes, live ranking and continuous progress tracking to upgrade your skills. Coming to support, if you have doubts, how can we support you? We have a quad core teaching model where we have an AI 24/7 doubt help system in which you can upload your doubt in the form of a text, photo or a voice, and this is present 24/7 with unlimited chances to ask doubt, because every student has different studying time, right? Someone would be studying in the morning, someone would be studying in the midnight, so AI is really helpful in that. Coming to one-on-one mentor sessions, if you have more doubts or guidance, we would be supporting with 1:1 mentor sessions, and you can always contact your master teacher from morning to evening with a minimum waiting period of 2 minutes and the maximum waiting period of 9 minutes. We will also be providing you a AI plus mentorship, teacher mentorship. Coming to self-study, how are you gonna practice? Coming to self-study, this is the most important part. We will be providing you with daily practice problems, digital study material and worksheets, Nana. Okay. Now coming to mastering it. After you have studied, your doubts are cleared. Now what's the next part? It is giving exams, Nana. We'll be conducting bi-weekly tests and mock tests or test series with which you can upgrade yourself and know where you stand. Coming to the prices, we have 8th, 9th and 10th for 39,999, 44,999 and 49,999. The multi-class package would cost you less, where 8th, 9th and 10th would be 89,999, 9th and 10th would be 65,999 and 8th, 10th, 11th and 12th would be 2 lakh rupees. Let me tell you, this has been done and there are only few seats remaining for this. Around 20% of seats are remaining, right? Now let me give you a surprise or special discount. It is only offered till the JEE live sessions are going on YouTube, where you'll be getting grade 8, 9th and 10th for rupees 14,999, 15,999 and 16,999. And the multi-class packages would be 8th, 9th and 10th would be 39,999, 9th and 10th would be 30,999. And this is over, guys. So guys, please hurry up and check the link in the description for further information. And please download the SISYA Class, which is present in App Store and Google Play Store, or scan this link. You'll directly redirect it. Thank you guys. Please like, share and subscribe. Have a great day.